Back at it. So I'll show you this, and I will show you.
Don't forget to hit record.
I did.
Gasoline direct injection is an
Can you hear that?
prevalent drive system for passenger cars worldwide. The growing demand for low
that too
fuel
loud?
consumption and stricter emissions limits calls for innovative engine concepts.
Is that too loud?
No,
I mean,
go
is it
louder
better?
even.
I couldn't hear you, Michelle.
If you go a little louder, it will be fine.
That's all it goes. Let's try
Okay.
it.
2020, 1/4 of all vehicles worldwide will be equipped with the gasoline direct injection system. Engines with gasoline injection create the air-fuel mixture right in the combustion chamber. This results in higher compression, thus improving efficiency.
Now, as you can see, you've got the spark plug right here, and you've got the injector right there, just like where it would be on a diesel motor. See, they're right next to each other. My drawing was not, it was not accurate in placement. The idea was.
Torque and driving dynamics are increased, while
Hey, Rudy, how come the car's going down the road, but the drive shaft's not turning?
Because it's moving so fast you can't see it.
in combination with turbo and downsizing, gasoline direct injection offers the potential of lowering fuel consumption and CO2 output by around 15%. Additional optimizations can be made with functional features such as scavenging and CVO. The Bosch offering for gasoline direct injection comprises coordinated systems technology, as well as a comprehensive portfolio of individual components. To supply fuel, Bosch offers the fuel supply module with an electric fuel pump, fuel tank, and medium pressure sensor. These components provide the necessary amount of fuel from the tank right up to the injection. The fuel is compressed by the high-pressure pump to the required pressure level of up to 200 bar and stored in the fuel rail. There, a high-pressure sensor measures the current pressure. Mounted on the fuel rail are high-pressure injectors that meter the fuel and spray it under high pressure right into the combustion chamber. Bosch injectors with innovative laser-drilled spray holes provide maximal flexibility in spray configuration while minimizing wall wetting in the combustion chamber. To achieve the best possible combustion, during gasoline direct injection, the air-fuel mixture is created right inside the combustion chamber. The intake air control supplies the engine with the correct amount of air mass at every operating point. One input variable is the amount of air taken in, which is measured by the hot film air mass flow sensor.
No.
Later on, the intake manifold low pressure sensor measures the air pressure. The throttle body controls the air supply to the engine cylinders by enlarging or reducing the diameter of the intake manifold. The air-fuel mixture requires an ignition spark to combust within the engine cylinder. For this, the ignition coils generate a high voltage of around 30,000 volts, store it briefly, then transfer it as a high-voltage current impulse to the spark plug. Turbocharging enables a larger air mass to enter the combustion chamber. Thus, more air-fuel mixture is combusted, improving performance. The exhaust gas turbocharger uses the energy of the exhaust to compress the intake air. With gasoline direct injection and exhaust gas turbocharger, engine displacement is reduced, enabling the implementation of downsizing concepts. The loss of engine performance resulting from reduced engine displacement is compensated by the turbocharging. Optimization of the individual operating points creates engines that deliver low fuel consumption and CO2 output with no loss of performance. Turbochargers require a certain minimum engine speed to attain their charge air pressure. If the speed is too low, a turbo lag occurs. Scavenging is the system innovation from Bosch that works to counteract turbo lag. To this end, the intake and exhaust valves are open simultaneously for a moment. This creates a dynamic pressure differential between the intake and exhaust sides of the engine. Fresh air flows into the combustion chamber and flushes the exhaust gas from the cylinder through the open exhaust valve towards the exhaust manifold. The increased flow of exhaust gas creates 50% more torque at low engine speeds, counteracting turbo lag. Bosch Engine Control supplies the numerous functions that an efficient engine management system must provide. The driver's wish for more or less torque is an important input variable for the electronic control. The accelerator pedal module supplies the driver's wish as a sensor signal. The crankshaft sensor registers the speed and position of the crankshaft. Additional data is provided by the knock sensor, the temperature sensor, and the camshaft sensor. Exhaust gas treatment from Bosch contributes to compliance with international emissions regulations. The planar wideband lambda sensor and the switching type sensor measure the oxygen content of the exhaust, thus providing the engine control unit with basic information for the correct mixture. Future legislation regarding particulate reduction presents new challenges for combustion engines. With the unique and innovative system solution Controlled Valve Operation, or CVO, for engines with gasoline direct injection, Bosch has successfully employed mechatronics to make a major contribution to achieving compliance with future statutory emissions limits, such as Euro 6 and SULEV. Key components of CVO are the Bosch engine control unit and the Bosch high-pressure injector. Contrary to the conventional pilot-controlled injection, the control unit and high-pressure injector operate in a closed-loop system. During the injection, the control unit measures the activation signal and determines the opening and closing of the valve needle to compute the duration of the open phase. Thus, the electronic control unit can calculate the actual injection amounts of every injection and readjust if necessary. This type of closed-loop activation makes it possible to meter even the smallest injection amounts with minimal tolerances. The precision of the gasoline injection is thus significantly improved in this area and is maintained throughout the working life of the valve, guaranteeing a stable combustion procedure. Gasoline direct injection from Bosch is a key to clean and economical engines. Fuel consumption and emissions reductions, as well as increased driving dynamics, thanks to direct high-pressure fuel injection into the combustion chamber. In collaboration with automobile manufacturers on developing gasoline direct injection, Bosch contributes a comprehensive portfolio and many years of know-how. With over 50 million injectors and more than 10 million high-pressure pumps, we are now celebrating 2 impressive production anniversaries. Our system's competence enables us to achieve
Well, it's turning into an ad, so we will go somewhere else on that.
What is engine displacement?
Engine displacement is, well, let me show you. Let me get back here, though. Thank you for asking.
What were those 2 new emissions that Europe's getting ready for, or BMW is?
One of them is particulate emission. You know, they're going after basically soot, which would be carbon.
And the other was the SE something or other?
Yeah. And the other one I'm not sure of. But the question is, what's engine displacement? Well, here you have a cylinder, and here you have a piston in that cylinder.
In the cylinder.
Yeah. And it's going to have rings. Right, and then connecting rod, whatever, however you want to do it. Okay, so what is this dimension right here called?
Cylinder.
Bore.
Yeah.
Bore.
In automotive, we call that the bore.
Oh, bore.
But from here to here, this is the diameter.
Yeah. For radius.
2 times the radius.
Yeah, 2 times.
Pi r would give you the area, actually. But this right here, because the piston's eventually going to get up to here, right?
Thrust.
What's this distance from here to here called?
Thrust.
Height.
Travel.
Yeah, well, in automotive, we call that the stroke.
Or stroke or thrust. Okay.
Yeah. Stroke being the distance the piston travels in the cylinder. So if we want to find out what engine displacement is, equals 4 times stroke. So for instance, if we had a something divisible by 8, 6.4 liter, 6.4 liter engine. That's 6,400 cubic centimeters, right? Because there's 1,000 cc's, cubic centimeters, equals 1. What's L stand for?
Liter.
Yep.
So mine being a 3.5 liter means it's a 3,500 cubic centimeter.
Yeah. Now, the reason I picked 6.4 is because it's easily divisible by 8 cylinders. So if this has 8 cylinders,
Divided.
you got 6,400 divided by 8 equals 800 cc per cylinder. Which means this up here is 800 cubic centimeters. That's what they mean by displacement. It's the amount of air that you can pull into the engine.
Okay.
So it's cylinder displacement times the number of cylinders. Make sense?
Yep.
Now, why would we want to increase displacement, right? Because we were looking at offer up today, and there was a 69 Camaro there with a 500 cubic inch engine, and there was another 69 Camaro with a 595 cubic inch engine. Why would we want to have more displacement?
That way you could slam more air in that cylinder.
More air and fuel, right?
Yep.
Yeah.
More horsepower.
Yeah, more air and fuel, which explains why, you know, if someone has, say, a 4.8 liter or a 5.3 liter in their car or truck, and they put a 6.2 liter in there, the fuel system's not going to be adequate to it. Is that going to give you a long-term fuel trim issue?
Yep.
Yeah, it is. In fact, it's probably going to be such a significant issue that the computer's not going to be able to compensate. So what do we have to do to get our fuel system to work with a bigger engine?
Upgrade the fuel pump.
No. Well, yeah, we might. But what I was thinking is we're going to have to reprogram that computer, right?
Yeah.
Yeah. For more pulse width or less?
More.
More. Yeah, exactly.
Way more.
Yeah, the more air and fuel we can get into the cylinder, the more power we're going to get. That's why, though, going the opposite direction, if we want to save gas or if we want to lower emissions, what are we going to do to the cylinder displacement?
Shrink it.
We're going to go down. Yeah, good. Okay. That's
Or
economy cars always have smaller engines, yeah?
in some of the Chevys, they do cylinder deactivation.
Right. Yeah, but I don't want to get into that right now. But they brought up something in that video that I thought was really important. Manufacturers are using direct injection and turbocharging to make the engine smaller. You think that's a good idea?
No.
Yeah.
Well, it's a good idea if you're the first owner.
Yeah.
But you know, I was going to school with a whole bunch of professional Toyota technicians. You know what they told me about turbocharged cars?
They're
Don't buy
terrible.
them.
No, they're fine, but you need to get rid of them before the warranty goes out.
Yeah.
I mean, putting a turbocharger on your engine is like using speed or drinking energy drinks.
Does it just wear out faster?
Yeah, it's just going to wear out faster. Yeah. You know, because if I fed my dog coffee, it could run faster, right? But you know, not for long. Or I could put a backpack on it. And that's a good idea. I could have them actually do work for me. But you know, yeah, but it wear them out faster, right? So, cylinder displacement is how much each cylinder can hold. And then you multiply that by the number of cylinders and you'll get total displacement. Now, I'll bring this up because I may not have covered. Oh, I'm sorry. Do you have that?
Yeah.
Yes.
Okay. Because there's two cylinder displacements that we need to be very concerned with. One of them is, I'll just draw it like this. Here's the cylinder, side view. What does side view mean?
You just
Looking
like
at it from
you
the
said
side.
first
We're looking
side
at
of
it
it all.
from the side, okay. So I'm going to come like this, and my piston is at the top of its travel. And then this comes like that.
TDC.
That's called TDC, which stands for what?
Dead center.
Top.
Dead.
Top dead
Dead center.
center. Yep. Okay. That means the piston's at the top of its travel. That means the cylinder displacement is now what?
Very small.
Zero.
Yes.
I mean,
This
yeah.
is the
Well, that's it.
cylinder displacement at top dead center. Can you see it's very small?
Mhm.
Okay. Well, now over here, same cylinder, same piston, but this piston's at the bottom of its travel,
BDC.
as far down as it goes. Yep. So this is going to come like that. Yep. That is
BDC.
bottom
Dead center.
dead center. Now, what did we say that the distance between here and here is called?
Stroke.
Yep.
Stroke.
Yeah, it's the only stroke I want anything to do with. And as you
Yeah,
can
really.
see, yeah, strokes are terrible, man. Except for the band, first couple albums. As you can see, the cylinder displacement at bottom dead center is way more. Now,
Larger.
let me
Larger.
pens. Okay, so I'm going to say displacement at TDC over displacement
At
at
BDC.
BDC equals what?
Total compression.
Close. Ah. Ah. compression ratio.
Mm.
You ever heard of compression ratio?
Yeah.
Yep.
That's how it's calculated. We take this volume and this volume and we put them in proportions. So a typical compression ratio would be
8.2 to 1.
that's really low. Yeah, sure. 8.25 to 1 or 10 to 1, or on a what direct injection enables us to do, and what running E85 enables us to do, is run really high compression ratios like 13 to 1.
15 to 1 or
So the question is, you know, they can manipulate the compression ratio by doing weird things with the valves. That's what the video was talking about. They're manipulating the valves in strange ways in order to vary the compression ratio, for instance, on a vehicle, which is cool, but you can imagine that's hardcore engineering to make that happen. So what does compression ratio matter? Well, because the higher the compression ratio, the hotter the air-fuel mixture is going to get, which has one good thing and one bad thing. The good thing is it's going to vaporize the fuel like crazy, which means it's going to make us much more efficient combustion. What's the bad thing?
NOx.
Yeah, it's very, very possible to get the air-fuel ratio so hot that what happens?
It ignites.
It ignites before the spark plug fires, yeah?
Right.
You
Right.
guys got this?
Yeah.
Okay. You guys got this?
Yep.
Yeah.
So, high compression ratios are very efficient. Why?
Because they atomize the fuel better.
Yeah, they vaporize the fuel much better. Ah. But and cause pre-ignition. Ah. Now, pre-ignition has a definition. What's the definition of pre-ignition?
Detonation.
Fuel igniting before the spark plug fires.
Yeah,
Yeah. Pre-detonation.
fuel ignites before the spark plug fires. Is that a problem?
Yeah.
Can be.
Yeah, because it means we've lost control of ignition. And that's bad.
Yeah.
And in some diesels, that's what causes them to run away.
Yeah, because, you know, Chuck and Rudy have correctly identified this causes what's called detonation. And detonation is extraordinarily destructive to the engine parts. Because, now, let's go back though. What made the air-fuel mixture ignite?
Heat.
The heat from compression.
It wasn't, I mean, before the spark plug fires, what made it ignite?
Heat.
Was the heat.
Absolutely. So basically, it's running like a diesel engine, right?
Yeah.
And remember, diesel engines have super high compression.
That's the only way they work.
Like 22 to 1,
Wow.
twice as high. Yeah, that's why you need a much stronger starter on a diesel motor. It's got twice as much compression. It's going to be twice as hard to turn over.
They don't have spark plugs, right?
Right. Yeah, because they're what's called compression ignition engines. they light off the air and fuel by while we're here, let's review. On a diesel motor, when I come down on the intake stroke, am I pulling in air and fuel?
Yeah.
No, you're just pulling in air.
No, I'm just pulling in air. Because what's going to happen is I'm going to compress that air so much that if there was fuel in it, it would just explode. So I'm going to compress that air so much, it's going to be super, super hot. Now, at the point where a spark plug would fire in a spark ignition engine, the injector is going to unload on a diesel motor. And as soon as it sprays that fuel, it's going to start to ignite because the air is so hot in there. And that's how a diesel motor works.
Okay.
Okay?
Mhm.
Now, my question to you is, before I go further on that, if I get ignition of the air-fuel mixture while the piston's still down far enough in the cylinder, could it try to push the crankshaft backwards?
Yes.
Yeah, and that's how pre-ignition beats the hell out of your bearings. It'll destroy your motor.
Mm-hmm.
Besides making it run in an unpleasant manner, it'll destroy your engine because if the piston's low enough in the cylinder, it'll try to push the piston back down on the compression stroke. And when it does that, you're going to end up with just beating the bearings out of the engine, which is not a good look. Let me ask you a question. Do high operating temperatures make pre-ignition more likely?
Make what more likely?
Pre-ignition.
Yes.
Yeah. Which is why when your engine is overheating, it starts running really bad. That's another reason why. Now, what about if I have carbon deposits on the top of my pistons? What are those carbon deposits going to do when the engine's running?
Make it run leaner?
Well, it is going to jack up your displacement, but the primary problem we're going to have with carbon deposits is that they're going to glow orange. Now, do you think that glowing orange can ignite the air-fuel mixture prematurely?
Oh, yeah.
Yes.
Sure. Yeah, sure. Absolutely.
Yes.
So I wanted to deal with that before I go to the next step, because the next step's kind of important. Typical compression, which is to say the pressure that's created by the compression stroke. Typical compression pressure. You ever do a compression test? It's one of the tasks you're supposed to do to graduate this class. Typical compression pressure is approximately 150.
120
What's PSI?
pounds
Pounds per square inch.
Good. Pounds per square inch. Good. Now, this is typical compression pressure on a what kind of motor?
Gasoline.
Yeah. This is typical compression pressure on a gasoline motor.
What is it on a diesel? Must be double that.
3 times that much.
You got it, Jim.
Yeah.
You
Yeah.
got it. So, can you use the same compression tester on a diesel motor? Not you.
No.
No.
In fact, usually they aren't going to do much in the way of compression testing on a diesel motor because you got to pull the injectors. Usually, that would suck. So, typical diesel compression pressure, not ratio. What creates compression pressure?
Piston moving up.
Compression stroke.
Stroke.
Good.
Stroke
It's probably going to be more like 300 psi. Now let's think about that. Because that injector is going to fire on a diesel motor. That injector is going to fire into a cylinder that's already got compression.
Those injectors are really, really strong too.
Yeah. Well, I was going to say, now a direct injector on a gasoline motor is going to have to inject into a cylinder that's already got compression too, right?
Yeah, but it doesn't have to be quite as stout.
Yeah, that's true. Yeah, that's true. But it's got to be a lot stouter than a port fuel injector.
Yeah, by far.
Okay, let me ask you a question. You done with this, guys?
Mhm.
Yeah.
Yep. Oh, like that. Okay, so let me ask you a question. I've got a cylinder right here. Piston's coming up because we're a compression stroke, right?
Mhm.
Mm-hmm.
Piston's coming up on the compression stroke. Up here's my, oh shoot, doggone it. Oh, now I broke my own heart. There we go. Doggone it. Pay no attention to the man behind the curtain. Doggone it.
That's a dome piston?
No, that's just the piston. This right here is the injector.
Okay. So it's a dome cylinder head.
No, yeah, this is the combustion chamber. Okay, does that make sense?
Yeah.
Mhm.
This is the combustion chamber. This is the top of the piston right here.
Okay.
Thanks for asking. Now, this is the direct injector. So let's say I got 300 PSI right here. Okay, diesel motor. Okay, let me ask you a question. If I have, how much fuel pressure do we have on a typical gasoline fuel pump?
About 50 pounds? 50, 60 pounds?
50, 60 pounds? Yeah, that's after the regulator, yeah. Okay, so 50, 60 pounds. Let me ask you a question. If I have 50 or 60 pounds here and I have 300 pounds here, what's going to happen when I
The
open the
pressure
injector?
will escape into the fuel injector.
Yeah, you're actually going to push air into the fuel injector. So I got two balloons, right? I got two balloons that are connected by a piece of pipe in the middle. In here I have 100 PSI. In here I have 0 PSI. Yeah? Will I
Yep.
have flow?
Yes.
Which direction?
100 to 0.
Until when?
Till they equal 50 each side.
Right, till they equalize, right? Because the pressure is going to create flow, yeah?
Mhm.
Okay, I got two more balloons connected by a piece of pipe. This one has 1,000 PSI. This one has 0 PSI.
A whole lot more flow.
Not only will I have flow, but I'll have a lot more flow. Why? Because the difference in pressures between these two is greater, yeah?
Yeah.
Yeah.
Okay. Let me show you how the intake stroke
That's
works.
why your diesel engines usually run like 60,000 PSI at
30.
their injectors.
Yeah, 30. Yeah, typically 30. Okay, so let me ask you a question. If I have 0 PSI here and I have minus 15 PSI here, will there be flow?
Yep.
Which direction?
Towards
Minus
the
15.
minus.
Goes the other side.
Flow always goes from where to where?
From high to low.
Yep, from high to low.
7.5 negative.
So, what's a negative pressure called?
Vacuum.
Vacuum or suction? Sure, absolutely. Good. This is how the intake stroke works, folks. Because when we pull the piston down on the intake stroke with the intake valve open, the pressure inside the cylinder is less than the pressure outside the cylinder So we have flow. That's what creates flow. And that's why when your engine's worn out and your rings get bad and you can't pull as much negative pressure inside the cylinder, your engine doesn't put out as much power, which is why when your engine's worn out, the primary symptom is going to be low power, right? Okay, so what are we going to have to do to get this injector to inject fuel into the cylinder, not push pressure into the injector? What's going to have to be?
You have to make a greater pressure in the fuel system, in the injector.
Now, let me ask you a question. Did you see how the difference in pressures is going to determine the rate of flow?
Yep.
Okay, so let's get this up to 30,000 PSI. Now, what's going to happen when we open the injector and we got 300 PSI in the cylinder?
It's gonna be enough flow.
Yeah, it's going to squirt like crazy.
Mhm.
Now, let me ask you a question, though. How much do you think it costs to buy a pump that puts out 30,000 PSI?
A lot.
Crazy expensive. Crazy expensive. Yeah, seriously, crazy expensive. Which, I mean, that's one of the problems we're going to have with these super efficient engines, because they're super efficient, but man, if anything goes wrong, it's going to be really expensive.
Yeah.
So, did you notice in that video, and you can watch that video again if you want, it will make better sense probably. Did you notice in that video that they were talking about the high pressure fuel pump?
Yeah.
Yeah,
Yep.
high pressure fuel rail and stuff like that. Yeah, it's because they really got to kick up the fuel pressure to make the direct injectors work.
Did you see that fuel pump that was running off the cam on
Yeah,
top of the motor?
yeah, yeah. I hope you're changing your oil, because I got to tell you, that cam is dealing with a whole lot of force. You know, this is a whole lot of force. Hey, what are you gonna put? You got this?
Mhm.
Mm-hmm. Yeah.
Here you have a cam lobe, right? It's just a circle with a bump on it. And here you have the plunger that goes to your high pressure
Fuel pump.
fuel pump. Why do you think they're running it off a cam instead of electrically?
Can't generate enough power.
Can't generate enough power, yeah. It'd be sucking up like 20 or 30 amps probably all the time. So right here, where this thing is making contact, you got friction. Did I say this? Friction like crazy?
Oh, yes.
So what are you going to do to bring that friction down?
Keep your oil change.
Run
Yeah,
better
your oil
oil.
clean, that's for sure. I'll tell you what I'm going to do. My cam lobe like that. What I'm going to do is I'm going to put one of these things like this. Ah, killed my drawing. Shoot.
A roller cam.
Damn right. Then I'm going to go to my high pressure fuel pump with my little plunger right here.
Yeah, then the trunnion's gonna wear out.
Yeah, that's what you got to watch out for, because this thing is a roller. And what does the roller do to the amount of friction between
Reduces
the
it.
plunger?
Spreads the load over a little more area.
Much less. There you go. Now, do you think most engines are running roller cams now?
Yes.
Well, now you know why. Because the two greatest sources of friction in an engine. Two greatest sources of friction in an engine. You ever built an engine?
Nope.
No.
No.
Not by myself.
Well, when you build an engine, you'll see what makes it hard to turn the crank. Now, if you just have the crankshaft inside the main bearings, is that going to be hard to turn by itself?
Mhm.
No, you can spin it pretty easy.
Oh, okay.
Number one and number two. That would be
Compression.
lifters. Now, compression's not a friction. That'd be lifters on the cam.
Get off of there. Sorry.
That's why I put roller bearings.
Which is why we put roller cams. Yeah.
Yeah.
Now, Chuck's brought up an important point. In order to get those rollers to roll, they have to have little bearings in them. And the problem is, if those bearings get overloaded or they don't get sufficient lubrication, they're going to fail. And then you're going to have significant problems. Hopefully, you don't need a cam. But you'll
Or a
notice
pump.
that, you know, the engine, it's easy to spin the crank when there's no pistons. When you put the pistons in, it gets harder. And when you put the camshaft and the rockers in, it gets extraordinarily hard. Just besides the fact that you're, you know, well, if you leave the spark plugs out, are you going to be able to build compression?
No.
No. Okay. So, number two thing is ring contact with
Cylinder walls.
Yep. Now, both of these have been addressed on modern engines. With varying levels of success. Now, we addressed the lifters on the cam issue with roller lifters. How did we address the ring contact with the cylinder walls issue?
I remember Ford was talking about low friction rings on their 5.0 engines years ago.
And they suck. Yeah. You got this? Can I go to the next page?
Yep.
Yeah.
Yep. They're called low tension piston rings.
No tension.
And you say to yourself, well, that's nice. They don't push against the cylinder wall as hard. That's nice.
They also don't control the oil as well. Or
They
the
don't control anything as well.
Yeah.
The problem is how hard they're pushing against the cylinder walls is going to determine how well they seal. But they're not pushing as hard against the cylinder walls. As a result,
Yeah,
if the engines get old, what do you think happens?
Leaks.
They lose their
Blow by.
compression rapidly.
Good. Yep.
Blow by.
Yep.
Mm.
And
Blow by.
oil control issues.
And oil control issues. Yeah, of course. Now, my question to you is, what's the definition of blow-by?
Compression blowing past the
Crank pressure.
Pressure exhaust.
Yeah, it's crank gases in there in the engine.
Yeah, it gets past the rings or whatever.
Yeah, there you go. Yeah, it's in your notes. Compression gases getting past the rings
Ring.
and into
the oil pan.
the what?
Oil pan.
Let's call it the crankcase.
No, that works too.
Yeah.
Hey, I got a question for everyone.
Okay.
How do you know if you're having blow-by?
What?
How do you know if you got a blow-by problem?
How much blow-by you have in your engine?
Smoke?
Nope. Smell your oil.
Oh, that's right.
If it smells like gasoline, you got a lot of blow-by.
Okay.
Yeah.
Or you could have a stuck injector.
Yeah, well, that too.
Here's how I would check for blow-by. What I'm going to do is while the engine's running, I'm going to take off the oil filler cap.
Uh-huh.
That makes sense?
Yep.
Yeah.
Yeah, so I'm going to take off the oil filler cap. There should be a slight vacuum. What creates that slight vacuum, Chuck?
Hmm.
I have to say goodnight,
The
everyone.
PCV valve.
Good man. Thank you.
See y'all next Thursday.
What?
I think about that one.
Yep.
I shall see y'all next Thursday.
All right, Rudy. Thanks so much. Good to see you, man.
Bye, everyone.
Hey, bye, Rudy.
Bye, Rudy.
Thanks, my love. All right, so my question to you is, how often should you change the PCV valve?
A lot.
Yeah. Now, you can shoot a bunch of throttle body cleaner into it and kind of, do a marginal job, but every time I buy a new vehicle, I just get another PCV valve. How much does a PCV valve cost?
$10.
Not very much. Ever. Not very much.
$8,
Yeah.
$10, something like that. Yeah. Okay.
The rubber hose is probably more expensive than the valve itself because they all got a special bend.
True that. And
Yeah.
then,
And the grommet. And the grommet for the PCV valve.
right. This is usually going to go
That crap.
to the valve cover, yeah?
Mm-hmm.
Couvre de
Yes.
valve. Where's the valve cover located?
On top of the valve.
Oh, the valves.
How do you know all this stuff, Norman?
Hey, we got a great teacher, man.
Quack.
Yeah.
Yeah,
We have Dr. Auto.
that's
Quack.
Dr. Auto.
Sir Fix-a-Lot.
Yeah.
Well, good. I'm glad it's working for you. Yeah, positive crankcase ventilation was the first emission control system, because what we used to do is we used to just run a vent right here, and we used to vent all the extra blow-by, and the
That's
blow-by
right,
was filled with hydrocarbons, just like Rudy said. It was filled with hydrocarbons, atomized fuel and atomized oil. So PCV system is a big deal. It's got to be running correct. It's got to be running correct. And there's all kinds of vacuum here. If you got a problem with this hose, or if it's leaking, it's going to cause big problems. How will you know if you have big problems with this vacuum hose?
Car won't auto right.
Well, that's true. What about when you use a scan tool?
Oh, it'll give you a code.
Mm-hmm.
No, not unless it's really bad. Go
Fuel
to
trim is
Google.
going to change.
What's it? What?
Fuel trim will change.
That's exactly it. Yeah, you're going to see it on long-term fuel trim. Good, wonderful.
How often should you change that?
Probably every 60,000 miles.
Okay.
Yeah, you can either clean it or change it, but for most people, depending on how hard it is to get to, for most people, it's just easier to change it. It just pops out, pops in.
Yeah.
Done. And then you don't have to wonder if there's a big clump there somewhere. Okay, so here's the problem with low tension piston rings. They're not pushing that hard against the cylinder. As a result, if you don't change your oil, you're going to get stuck rings a lot. Because, are you done with this?
Yeah.
Okay. Now I'm going to draw you the piston with no rings in it. I got confused.
No air compression.
That is a piston without rings. And see here, here, and here is where the rings go. And I'm just going to come up like this. Make sure you understand it's a piston. There you go. Make sense?
Mhm.
Okay. So, are you going to get oil up here? Do the rings need to be lubricated?
Mm-hmm.
Yeah, you should.
Yeah,
Something
they do. So you need to understand that that oil control ring, by design, has to let a certain amount of oil up there. Plus, you're going to have a little bit of oil coming down from the valve guides. But whatever the case, we need to make sure those rings are lubricated, because the rings, if they're not lubricated, they'll just open up the bore. Open up the bore like this, right? Premature
The drill, yeah.
cylinder wear. So here's the problem. If you have low tension piston rings, incidentally, are those rings going to spin in the bore?
They should.
Yes.
Yeah, they
Yeah.
better. Yeah, they freaking better. Because one of the problems you got to remember, that's a piston ring. What's the space between two ends called?
Ring gap?
Yes, sir. Yep. Why do we have ring gap?
Expansion of
You don't
heat.
want them breaking.
Expansion, exactly. Because when this gets hot, what's going to happen to the length of the ring?
It's gonna get
Yeah.
bigger.
It's going to increase.
Expand.
And if this is inside a cylinder, it's got no place to go except closer together, right?
Mhm.
Now, what do you think would
Yeah.
happen if those two ends of the ring touched?
Damage.
It would break.
Yeah, it'd score the hell out of the cylinder, probably weld together. It'd be very, very bad. Don't do that. So one of the things when we're building a motor, we need to make sure that the ring gap is correct. What is it, 4/1000ths for every inch of cylinder bore? That's what it used to be. I'm sure it's different now.
Well, what about the ring gap between a turbo engine and a normally aspirated engine? I'm sure they're
Sure.
going to be different.
Yeah, absolutely. So we got to be very, very careful with the ring gap. How do you measure the ring gap? Do you know?
Feeler gauge
Feeler
right
gauge.
there in the.
That's what I was gonna say.
Yeah. Yeah, what you do is you take the ring and you put it in the cylinder. You put the piston upside down to push it down so that it's
Square in the bore.
square in the bore, and then you use a feeler gauge to measure it. Yeah, very, very important. You know, and then they actually have a little tool that you grind the end of the rings. Lots of people don't do that, taking a risk. Anyway, my point was, as the engine gets hot, the ring gap's going to get smaller. Let me ask you a question. As the cylinder wears, what's going to happen to the ring gap?
Get bigger.
It's bigger.
It's going to get
Increase.
bigger. And as it gets bigger, what happens to blow by?
More.
You
I get more of it.
You're going to get more of it, which is why another classic symptom of a worn out engine is a bunch of blow by, right?
Mhm.
Now, the PCV valve that we were talking about on the last page is supposed to maintain a continuous slight vacuum in the crankcase. That's its job, slight vacuum. How do you know? Well, what you do is you take a piece of paper,
Wow.
you take the oil filler cap off when the engine's running.
Ooh.
You should be able to put a piece of paper on the oil filler cap hole, and it should hold it. Slight vacuum. Does that make sense?
Yeah.
Yeah.
Now,
Good
I had
trick.
a Nissan, nothing against Nissans, except when I had a Nissan that if you took off the oil filler cap, it would be spewing, you know, up on the bottom of the hood. It had so much blow by.
David,
And
Yeah,
this one-
David,
What's it, what?
David, the other thing you have to have is the ring openings have to be staggered.
Oh, yeah. Although, I got to tell you, Arnold, remember, those rings are going to be spinning in the bore. So, that's kind of...
But if they're all,
Think about
but
it.
if they spin evenly, you always have a gap in between them. They won't
Right.
be in line.
Right. Yeah. So, since they spin, I doubt they spin at the same speed. But what Arnold's talking about is if both of the ring gaps are lined up, then it's a straight shot for a blow-by to go straight into the crankcase. That's why he said you got to stagger the ring gaps. Usually you put them 180 degrees away from each other. So any gas that wants to escape has to go through this one halfway around the piston and then to get out. It's going to give you less blow-by and higher compression. But here's the problem with low tension compression rings. I mean, piston rings. If you don't change your oil,
They're floating.
you know, there's oil here.
Mm-hmm.
If you don't change your oil, well, might be little dots right there. If you don't change
Okay.
your oil, what happens is it gets really sticky. It gets really varnishy. You know what varnish is?
Mm-hmm.
Mm-hmm.
Really sticky. It's like tar. It's like asphalt, really, because it's all the nasty stuff in the oil. And what happens with the low tension piston rings is they get stuck in these ring lands. They get stuck. So they not only do they stop spinning, but they stop expanding. So if they stop expanding, now you're going to lose compression like crazy, right? So on an engine that has low tension piston rings, it's even more critical that you change your oil regularly. You know, changing your oil is just a huge big deal. Most people don't care, but you should. You should. It's a big deal.
Wow.
Oh, shoot. Doggone it. I didn't notice. Nan, you made it. Hooray. Rudy's here. Nanan's made it. Hooray.
But very good.
Good, good, good. Yeah, one of the things I don't like about Zoom is that you can't really change the size of the windows. So I couldn't see that someone was waiting to get in. Nanan, how you doing?
Hi, sorry, I totally forgot about class.
Here we are.
Just want to say hi to everybody.
Hi.
Hey.
So glad you made it.
Yeah.
Good. Well, this video is going to be on YouTube later tonight, so you can certainly
Okay, great.
catch up. How much time we got? Oh shoot, we only got 15 minutes. So super important to change your oil. Hey Arnold, are you using synthetic oil and everything?
I am on my 55 also now.
Yeah, I use synthetic on everything.
You don't want to take an old engine and put synthetic right in it, though.
Right, you have to
Get
do
off
the
synthetic blend first for the first
Yeah.
oil change. But
I
yeah,
have a
First
question about that.
Breaking,
2 oil
breaking
changes.
in.
do you want me to tell you how I discovered that synthetic is the way? It's a horrible story. You want to hear
Yeah,
it?
tell us.
Yes.
Yeah.
No, Rudy, you can flatter yourself, but no. Rudy was the one that told me, but this is what convinced me. Twice I had students who should have known better, who were doing an oil change and they started the engine without oil. And because it had synthetic oil in it, it didn't even make noise. And we got
Wow.
it shut down on time and it didn't cause any engine damage. That
Wow.
to me was,
Okay.
after that, I was done. I was convinced. Yep.
Okay, listen, I have a question about that.
Yeah.
When I got all that work done on my car, I was using a blend, right? And I told them, I said, hey, I'm using a synthetic blend. And they said, oh yeah, we use synthetic blend. And then when they put it in, they just put in standard oil.
That's the good thing about the synthetic blend, though. You can go back and forth between
Okay.
it.
Yeah.
Just once you go full synthetic, you cannot go back
Right.
without going through the blending process again.
Yeah.
Okay, so I'm okay. I can just do the next oil change with the blend again?
Yeah.
Yeah.
Okay.
So why did they put regular oil in it?
I don't know, because I specified to them to use synthetic, you know? I don't know.
Really?
It,
Yeah, I told them.
it's because they don't listen to you
Yeah, I know.
as a woman. They just don't expect you know anything.
Well, they wanted to save the money, right? Because
Yeah.
it's a difference
Or
between
charge you.
about $5 a quart and about $9 a quart.
Yeah, but they wanted to charge you the synthetic blend.
Right.
Yeah.
Man,
Yeah,
that's
they say that
aggravating.
they say that you have to change it like within like 2 weeks or something after that. You have to drain it and then you have to put in your synthetic back in there.
No. That's if you went
I would.
full synthetic.
Yeah, I'm not
Oh,
full
okay.
synthetic yet.
The synthetic blend stage,
Oh,
then you're okay to run just the conventional oil
yeah.
for that oil change. If
Mhm.
you've gone full synthetic and then they put conventional in, you have 2 weeks before you can start causing issues
Yeah.
with the motor.
I'll
Okay.
buy that. Yeah. Sure.
Like I got scammed. I got scammed like 4 months ago as well, with like an auto mechanic and stuff like that. It was my mom's Mitsubishi. They had ripped out wires, the green and the red ones for the motor, and then he had done something to the motherboard for the switches.
Mhm.
Yeah, and they don't work no more.
Yeah, I heard that a lot about mechanics in your area, how in order to generate repeat business, they jack stuff up when they fix stuff.
Yeah, it's an LKQ.
Yeah, that's blows.
Horrible. Well,
Yeah.
Mitsubishi's tried to kill my father.
Oh yeah,
What?
that's brutal.
That's why I don't use mechanics.
Yep.
Yeah,
Okay.
I don't use mechanics.
Yeah. Seriously, really at this point. And Citrus shut down, and my student was right in the middle of engine rebuilding class.
Oh no.
Very unfortunate. Yeah. So doggone it. It's like I want to sneak into the shop and just like, here, do this. But, he was working on that Suburban, and I kind of had to walk him through a lot of it. But, that's how it goes, man. It's like you can't see what's going to save actual classroom learning is that, you can take online classes all you want on auto repair, but the simple fact of the matter is you have to get in there and get your hands dirty.
Yeah.
Or wear gloves.
Whoa.
That's in a lot of things too.
Yeah, of course.
Mhm.
But, I told you how University of Phoenix does their clinicals for RN, right?
Yeah, that sounds really good.
Yeah, you just go down to Florida for a couple of weeks and you do all your clinicals at once.
That's cool.
You can learn all you want about baking online, but till you actually bake a cake, it's a completely different.
Totally.
Yeah.
Oh yeah.
Seriously. And the same thing with working on cars, It's like because this young man's in the heavy truck program, and I'm like, you know what? If you don't know how to do the drum brakes on this vehicle, you need to do the drum brakes on this vehicle,
Yeah.
Because drum brakes are basically the same, just the parts are different.
Well,
a
the
whole
good
lot
thing is,
bigger.
yeah, because these brake shoes are 3.5 inches wide,
Wow.
Oh wow.
big suckers.
Yep.
Yeah, and they weigh a freaking 60 pounds a shoe.
Yeah, drum's heavy. So what I noticed, let me show you this.
Mm.
Are you done with this?
Mm-hmm.
Yeah.
Because I want to talk to you about a problem I had and what I think the solution's going to be, and I want to see where your head's at on this. Okay, on a drum brake, we have a wheel cylinder right here.
Mm-hmm.
And then we've got a little pokey thing that comes out here, and a little pokey thing that comes out there.
Mm-hmm.
And then we've got a brake shoe right here.
Mm-hmm.
Guess how I learned to draw brake shoes?
That's good.
Yeah, like that. And then this comes in like this. but there's hardly any
One
lining
is-
on this shoe.
Yeah.
There's big lining on this shoe. Ah,
A lot more.
but there's hardly any lining on this shoe. What's the cause?
Is this the rear of the car? The front? Of, which is front and
Front.
rear?
It doesn't matter.
Alignment's off, maybe?
Nope.
No.
Where the handbrake is?
This is the rear. So
You want me to explain what happened? They parked a few too many times with the e-brake on with hot brakes.
I don't.
And the drums have warped.
I don't believe you, because typically when you apply the parking brake, it's going to apply both.
Oh, I know, from riding the brakes when they drive.
Uh-uh.
No?
No, that would cause both.
Remember, Rudy, you've
A sticky shoe?
remember,
Stuck
Rudy,
wheel
that
center?
balance bar right here, right? And it's got a spring, right, Chuck?
Right? Okay.
Mhm.
Yeah, I seen that.
Yeah. So what happens is when you pull the parking brake, it pulls this lever like this, which is going to push the balance bar out like that, and it's going to apply both sides of the brakes. Now, what did you say, Chuck? What's your
I thought it could be a sticky shoe.
could be a
Um,
sticky shoe.
Wheel cylinder.
Could be a sticky shoe, like the backing plates where the shoes
Right,
Mhm.
have a
'Cause you-
groove in them.
right.
But usually, especially with an ABS car, you're generating so much pressure that usually it's hard to get this to not push out. I have a theory. Inside this wheel cylinder, right, because the brake line comes in like this,
Right,
you've got two pistons, right?
right.
Mhm.
Yep.
Did I mention that the fluid was blacker than,
Oh, yeah.
why is
Yeah.
the fluid
Yeah,
black?
so when the pistons were sticking,
That's what I think.
Yeah, the rear piston was sticking.
Yeah, well,
Yeah.
this piston is sticking, right?
Mhm.
Yeah.
yep,
Because when the brake, okay, first of all, how often are you supposed to change your brake fluid?
Every couple
Well,
of
I
years.
think,
I don't know.
yeah, every 5 years.
Every 5
5
years.
years.
Have you ever known anyone that changed their brake fluid every 5 years?
Me.
No.
I do.
I've never.
Me.
Oh, good. I've
I
never
do.
known anyone that changed their brake fluid every 10 years. So
yeah,
I do. I do.
good. Well, one of the first things that you want to do on a vehicle that you just bought is flush the brake system, because
The Flex have done the brake flush twice on.
what's it?
I do mine more ever since I started to get that, Mr. Rocliffe told us about that synthetic brake from, O'Reilly's. So I've
Yeah.
been converting all mine to that. So my
Oh.
cars are getting flushed out all the time now.
Which means you'll never have an issue with calipers, master cylinders, or wheel cylinders. Never. That's cool.
Yeah.
What is it?
Yeah.
Synthetic brake fluid?
Synthetic
Yep.
brake fluid, yeah.
O'Reilly sell it.
Yep.
AutoZone don't carry it.
But once
Or-
you
or
go
at least
that
not on
way,
the cheap.
it's just that way.
Well, because they probably don't want you mixing the synthetic with the regular. Now, let's talk about that for a minute. One of these pistons stuck. So what are you going to do? Rebuild the wheel cylinder?
Nope.
No, put a
I knew
put a
it.
new one in.
Arnold, are you going to rebuild that wheel cylinder?
Nope.
I would rebuild it. I
Oh.
rebuild them all the time.
Ever rebuild a
Knew
wheel
it.
cylinder, bud?
I knew it. I knew it.
They came in a lot cheaper.
Okay, look. Here's the wheel cylinder, cross section, right? Here's the wheel cylinder. Goes like this, and then all this rust has eaten out this part.
Yeah, it could be pitted.
Yep, it's all pitted. My question to you is, do you really think you're going to get this thing smooth with a hone?
Mm-mm.
Well, if it's that bad, if it's that
Not
bad,
without
you
a
gotta look at it.
machine hone.
Never in a million years will you get this flat with a hone. And I can tell you that you're not going to get it the same dimension from here to here.
No, there'll be a taper.
Yep. How much is it? How much is a new wheel cylinder?
$15. Yeah.
You know what the failure rate is on a new wheel cylinder? 0. You know what the failure rate is on a rebuilt wheel cylinder? A lot.
50.
Not worth it. Not worth it. We need to quit rebuilding master cylinders. What? We need to quit rebuilding master cylinders, quit rebuilding calipers, quit rebuilding wheel cylinders. Leave that to the professionals. Down the road we go. And we'll make more money on it too, because this is kind of a time-consuming thing. So that's the professional way to do it, according to Esteway. Okay, so I got the shoes. You know, I got these shoes. They're 3.5 inch wide. I got them for $35 at CarQuest.
Yep.
Good deals. For the good stuff, no less. Folks, let's do what we can to support our local small businesses, because they're really getting reamed right now, hard.
Roadcliffe, remember not to set the parking brake on that Suburban Hot.
Let's say what?
Don't set the parking brake on your Suburban Hot.
Right. Yeah.
Because remember, that's what we had. Remember the issue I had with mine.
Yeah. 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 What Rudy's talking about is a lot of times if the self-adjuster quits working, people will set the parking brake, or if the linings are very worn, they'll still set the parking brake. So what happens is when you try to put new linings on it, now you can't get the drum back on. So now you have to readjust the parking brake. I never readjust the parking brake. Are you listening, Chuck? Because this is Chuck and Arnold, because this is for you. If you don't adjust the parking brake, you can tell how worn the linings are by how far the handle comes up, which is cool because that's a good indicator, right? It's kind of like looking at the fluid level in the master cylinder reservoir. It tells you how worn out the linings are. That's why I never adjust parking brakes, and I never refill fluid levels on brake cylinders. I mean, brake reservoir.
Brake reservoir.
Yep. Mm-hmm. That's it.
Yep.
So do me a favor. We need to quit rebuilding this crap. Just put in the good stuff, and then, like Chuck says, put in the good brake fluid, and we will never, ever have a problem with it. Because I got to, okay, let me ask you a question. The failure rate on this, we have to all agree, is thousands of times higher rebuilding them than getting another one, getting a new, or even a remanufactured one. It's got to be thousands of times higher. Let me ask you, what's going through your customer's head when you have a comeback?
They're mad.
You did it on purpose.
First of all, they're mad. It's extraordinarily inconvenient. They're doing without their car for another day. It's just,
and they're assuming you did it on purpose.
Yeah, a lot of them could be, yeah. So, I mean, look, comebacks just make you look bad. Comebacks lose customers. And comebacks, okay, let me ask you a question. If I hone this wheel cylinder and it fails, is the customer going to pay me to do it again?
Nope.
Oh, they need to bring you the part.
You're not going to get paid the second time.
I'm not going to get paid the second time, and I have no desire to do that job twice. I hate doing the job once.
That's why you would nail it the first time.
Yeah. So, I mean, I'm just telling you, what we learned from years and years and years of building, heavy equipment transmissions. There are certain things you just shouldn't do, and using a hone is one of them.
Right.
I mean, what do I know? But I do know something.
Yeah, we got you.
I
understand what you're saying.
Well, I think the variable on this is that most cars, aftermarket parts are readily available, but in most classic cars, like a 49 Chevy, there are times that you just have to rebuild the same cylinder because
Yeah.
is
'Cause you
not
can't-
available
Yeah,
quickly.
because you can't get the parts, yeah.
True.
Right. So that's really where Arno and I come from, because we work the whole spectrum from old to new.
Yeah. Okay. Well, I mean, yeah, that's true. I mean, and if you're out in the jungle, you do what it takes to get the vehicle
Yeah.
on the road, right?
Most times we change the wheel cylinder, but I mean, I've used the Hone before in my younger days, in the
Right.
70s and 80s. That's, you buy the Hone with the spring loaded and you just brake fluid and do it.
Certain things we didn't know better, right?
Yeah.
But yeah, I mean, when there's a parts store on every corner, I mean, it's the same way. I feel the same way about rebuilding starters and alternators
Yeah.
and air conditioning compressors. How are you going to warranty this? Well,
Can't.
actually, I feel the same way about rebuilding steering boxes while we're on the subject. I mean, why would you have some mechanic rebuild a steering box when you could have some guy that makes minimum wage do it, who does it all day long? It doesn't even make that doesn't make economic sense.
Not to mention, that's all he's been trained to do.
Right. Yeah.
Is to rebuild that item.
Right. I mean, that's
It
the
looked
same
like a
thing.
charm pop.
I mean, are you going to have a general mechanic rebuild an engine? That doesn't make sense to me.
No.
Now, you're right, unless it's some funky engine that you can't find to rebuild.
Yeah.
But like early Ford 39 Ford transmissions. There's a bunch of people that specialize in that, and if stuff's pretty hardcore, I'd like to leave it to specialists. Just because, well, for instance, you look at the process that was going on today. It took them pretty much 4 hours to do one A-arm. That's what happens when you do it for the first time. You know?
True.
Sure look fast on YouTube, though.
Yeah, he made that comment
Yeah.
because he was trying like hell to get the ball joint separated from the spindle.
Yeah.
And I just had to go out there with my 3-foot long sledge and just beat the living crap out of the thing, and finally it split. But
Yeah.
Hey,
Live and
Rook,
learn.
a trick to that one, to get that ball joint to split a little easier, spray some WD-40 up from the bottom of the bolt.
yeah.
Spray that reverse of the taper. It will help sort of break that ball joint.
Yeah. WD-40 is the wrong chemical for that.
Or penetrating lube, or any of those.
Penetrating oil. Yeah, penetrating oil. PB Blaster or liquid wrench. Yeah.
Yeah, but spray that in reverse of the taper.
Yeah.
A couple good blows with the sledge, it'll come right out.
Yeah. Well, I have that. You got this?
Yeah.
Yes.
Oh no, the pickle fork. Oh.
You don't want to use that.
Yeah. I was told to never use that.
Well,
Never
yeah.
use that.
Let me ask you a question though. If you're taking off if you're taking off an upper A-arm and you're going to replace it, do you care if you destroy the boot?
Oh no, of course not.
Yeah,
Mm-mm.
bang that pickle
If you
fork in there,
replace
right?
it, no.
Yeah.
Yeah.
Of course, the good thing
I
about my method is when you use the sledge to separate it, then when you can see the condition of the ball joint, and when we separated the ball joint from the spindle, the whole thing just fell apart. They're really
Ball
bad.
joint was bad.
It's like my Suburban, remember?
Yeah,
That was like what happened with my Suburban
right.
when we had to replace the upper control arm
Right.
over in East LA.
What year was it?
Mine was a 96.
Yeah, it's the exact same thing.
No, 99. I'm sorry. It's the exact same as yours. Just mine was a 2-wheel instead of 4-wheel. Hey, Jim, nice to finally see you.
So that's the ball joint.
Mm-hmm.
Uh-huh.
Got the little thing sticking out right there.
Yep.
Yep.
That's it.
That is the upper
Controller.
A arm. Why do they call it an A arm?
Because it looks like an
Like an
A.
A.
Kind of looks. Because it kind of looks like an
Like
A.
an A.
Yeah. Okay, so you know you can work this ball joint all day long, or you can just get the A arm for like $58, and it's got a
Mhm.
brand new ball joint and 2 brand new sets of bushings. I would rather do the A arm all day long, but
It's way
again,
easier,
if you
huh?
can't get the parts, you can't get the parts, right?
Yeah.
So according to me, if you're not going to use this ball joint again, you can just come in with a pickle fork. But the problem we have is most of the shops around you guys, they're going to use a pickle fork on anything, and it's going to destroy every boot because this thing destroys boots. So they're going to use it for like the tie rod ends on the steering wheel.
Oh, yeah.
And then not replace the boots.
No, of course not, because if you don't replace the boot, that means we're going to have a failure soon, and that means we got more work. These guys are terrible. These guys are so terrible. It's like if you take your car to them, they will freaking destroy it
Yeah.
until you
I won't
run
tell
out
you.
of money. Until you run out of money, man. That's freaking brutal, man.
It is.
That's why I hate to see people take their cars to these mechanics. I mean, if you're going to take it to a legitimate mechanic like Connie and Dick's or Quality Auto or one of these places like that, yeah, go ahead. You're going to pay, but go ahead. You'll probably end up paying less because these people are going to diagnose it right the first time, and they're not
And
going to
not
rip you
just
off.
play the part guessing game.
Right. Yeah, exactly.
Yeah.
So, that's why, you know, I can't wait to get back in the shop, folks. I'll tell you that. I miss our little safaris in the shop.
I think we should all go over to Arnold's house and work in that garage.
Yeah.
Work on what?
I'll take
my
that
house
as a
and
yes.
what?
Yeah, we're all gonna come over and work in your garage, bud.
Your garage and work in
Yeah.
there.
Yeah.
Okay, Arnold, this
I
is
got all
my
the
question.
tools. I have all the tools.
Yep. Here's my question, Arnold. What's underneath that blue cloth?
Oh, that's a Harley.
Is
90.
it? Let me see it.
90.
Arnold, you keep being new surprises. Oh, that's the back. Oh. Woo! Arnold,
That's a beauty, bro.
that's beautiful. You're riding with Jerry.
And there's a truck in the back.
Wow, truck's beautiful, man. Arnold, what's
Yeah,
going
it's got
on?
I'm putting a power rack in it.
Really? How's that going?
Yeah. It's going good, except I'm losing pressure. I got to find out if the rack is bad or the pump is bad.
Yeah. Yeah.
I'm not getting any pressure on it.
Hmm.
So I've been doing. I just came back from Fresno where I was working on a '55 Chevy pickup for ground up restoration.
Really?
Yeah. So we put the engine in. We got all the rear end in, got the brakes in, got the bed wood cut, stained, and coated varnish. And I'm going back next week and try and finish all the wiring for it.
Wow. Wow, listen to you.
That's wicked, brother.
See?
Mr. Roadcliffe, you gotta hang out with the cool kids.
That's it. That's it, man. That's freaking cool. Okay. Well, shoot. Can't wait. So, are we going to see you next week?
Yes.
Good.
I'm going to try signing on from home, from Fresno.
Yeah. Yeah. I mean, did you guys find this useful or helpful?
Mm-hmm.
Absolutely.
Yeah.
Very good.
I mean, and for the situation we're in, I think it's a great solution. You know,
No.
Yeah, it's working out pretty good.
good.
Hey, real quick,
No,
did you
We need
say
flashcards.
on YouTube?
Flash them on us.
Well, I'll call people up and give them hell, but turns out when you don't have a YouTube monetary account, it takes forever to upload the videos. But I'll upload this video tonight. It probably maybe won't be available tonight, but it'll be available tomorrow. So yeah, we're starting to get a library of these class sessions. So next Thursday, you gonna make it?
Yep.
Can't wait to see
Yep.
you.
Okay,
Can't wait
thank
to
you.
see
All right.
You know, and maybe we should call Abel and Tony and give them crap before the meeting. So
Well, I tried to get a hold of Abel. I wasn't able to talk to him. I talked to Tony.
And
yeah, well,
He said he would try, but he had to go take care of his dog.
the hell,
Oh, yeah.
that's a new one.
yeah.
That's a new one. Well, folks, it's 9/11. I've had a wonderful evening with you guys. This, like I said, this is the best part of my week. I sure appreciate you being here.
Thank you.
For you.
Yeah, I get to talk to somebody else, you know.
Yeah, there you go. There you go.
Have a great week. I'll see you Thursday.
Okay,
All right.
everyone, have a good week.
Bye bye.
You know how to get a hold of me if you need to. Thanks, guys.
All right, later, bye.
All right.
Good night.